Hey guys, I hope you're having a great Thursday, and I'm hoping that you're staying on track with your learning plan. I'm learning some really great things over at the Leader and Me training, and I'm going to visit a school today that will allow us to see what it looks like to have a really great Leader and Me program established. But I wanted to go ahead and give you guys the opportunity to kind of make up for the test that we did yesterday. Some of us didn't get that 75% proficiency that we were seeking for, and I just saw a few misconceptions as to how we multiply fractions with whole numbers. So I'm going to go ahead and do a little mini lesson. Please follow through, and then I will see you tomorrow to take a reassessment on it. Okay, so remember that when we're multiplying fractions and whole numbers, we're ultimately probably going to get a result that is less than the whole number, because we're really making groups of fractions, or we're pulling a fractional amount from the whole number. So for example, let's say that I have 5 pounds of dishwashing detergent. 5 pounds of dishwashing detergent. And over the course of a month, I have, well, not pounds, sorry guys. Let's do gallons. I don't know what I'm thinking right now. So I have 5 gallons of dishwashing detergent. I bought it at Costco. And over the month, I've used about 2/3 of that. So I want to know what is 2/3 of 5 gallons. That way I can see how much I'm using, maybe to just take care of my purchases in the future. So what I need to go ahead and do is I can either go ahead and create a model of this, but I think to lessen our confusion, let's go straight to that standard algorithm that I saw many of you use, and then I want to show you what you are probably messing up on. So if I have 2/3, and remember, if you need me to stop and you need to pause this, you can do that. All of these notes should be in your journal. And I'm going to change 5 into a fractional amount so that I can actually go ahead and do this easy standard algorithm. So I'm going to go ahead now and multiply straight across. 2 times 5 is 10. 3 times 1 is 3. Now, we could stay at 10/3, but we don't go around, working towards, improper fractions in our life. Just unnecessary. So we use the process of division to make a mixed number. So let's go through this. How many 3's are in 10? Because I can probably pull out a few wholes, right? Remember, our wholes would be anything that's 3/3, 3 out of 3. I know that there's a relationship between 3 and 9, and there would be 3 3's in that 10, at least getting us to 9. So there's 3 wholes, and because we know that it's close enough with that 9, we're going to take away to find that fractional amount. 10 minus 9 is 1. So we now see that the amount of dishwashing detergent in gallons that I had used was 3 1/3. That one's a little bit more trickier because we did come out with a mixed number. Let's go ahead and let's focus on another example. And this one won't be mixed number based, okay? And let's inverse it this time. Let's go ahead and say I'm not pulling a fractional amount of, I'm making groups of something instead. So let's say I have 7 chocolate cakes, and each of them has only, let's see, trying to think off the fly, which is probably not the best idea. Let's say there's 2/7 of each cake left. So ultimately, I could make models, I could do the repeated addition, but we have seen that some of that could cause confusion for us. So instead, we're going to do this quick trick to find out how much cake we have all together. So really, right now, I have 7 groups of 2/7 of chocolate cake. Okay, so let's go ahead and do the math on this one. Again, easy peasy, standard algorithm. I have 7, changing it into a fractional amount, but it's still a whole because how many ones are in 7? 7 wholes. And now we go ahead and we're going to see how much cake we have if each of them contain 2/7 left. 7 times 2 is 14. 1 times 7 is 7. Now this is a perfect example of where we're going to see our combination of fractions together as wholes. So 7, how many 7s are in 14? We should know that there is an even divide. Thinking to ourselves, math fact base, 7 times 2 is 14. So there are 2 wholes left of chocolate cake. And I really do want to show you guys, like, if we were to do the repeated addition, you would see, like, okay, so this cake pan has 2/7. This cake pan has 2/7. This cake pan also has 2/7. This cake pan has 2/7. This cake pan has 2/7. This cake pan has 2/7. And last but not least, this cake pan. It's like when you're on a Friday night with your family and you have extra pizza left over from random boxes, and in order to fit it all into the fridge, you put whatever leftover pizzas from whatever boxes all together to see, like, oh, I can fit everything in one box. Now I have not 3/4 of pepperoni and 2/3 of cheese. I can go ahead and add those all into one box instead of, you know, random multiple boxes in our fridge. So this is my 2/7 of chocolate cake. And now what I would do is just add them all up. I get the same result as that standard algorithm. 2, 4, 6, 8, 10, 12, 14 sevenths. The same process from above, just a quicker way to solve. Again, your 2 wholes. So the math is still the same, different method, but it's what you're doing. You're creating groups of, or you're pooling groups of things when multiplying fractions. Thanks again, and go ahead and move on to the next video that is posted on multiplying fractions by fractions. And I will see you tomorrow. Be good. Bye.